Hi ladies and gentlemen, today we're going to be graphing and solving one-step inequalities. So we've graphed already simple inequalities. These are not simple inequalities because I have an operation that's attached to each one of these problems and my variables. So we have to undo that first to make it a simple inequality, and then we can graph the simple inequality. So we're going to treat this like we have our one-step equations, and I notice we're subtracting 15 from n, so to undo this subtraction, we're going to add 15 to both sides. So I'm left with n. I can get rid of the minus 15 and plus 15. I'm going to bring the greater than sign down, and 35 plus 15 is 50. So here's my simple inequality of n is greater than 50. So let's graph that. I'm going to put 50 in the middle. You can count by ones or I'm going to count by tens here. One number larger, one number smaller, space it out a little bit. And this greater than sign tells me it's going to be an open circle over the 50. And we're looking at numbers that are bigger than 50, so an arrow towards the right to all those bigger numbers. Now let's test it out. Let's substitute in 60 to see if it works inside our inequality. So 60 minus 15, will it be greater than 35? Well, 60 minus 15 is 45, and 45 is greater than 35, so that means 60 is a solution to our inequality, and I've drawn my arrow in the correct direction. If I substituted 40 in here, 40 minus 15 is 25, and 25 is not greater than 35, so that means 40 is not a solution, and I see that we did not shade any part of this in over here at 40. Let's take a look at the next one. Number 2. 3n is less than or equal to 33. Well, the 3 and n are being multiplied with each other, so to undo multiplying by 3, we're going to divide both sides by 3. I can cross these out. So on the left, we're left with n is less than or equal to 11. There's our simple inequality. Now we can go ahead and graph that inequality. I'm going to put 11 in the center. Let's put 12 to the right and 10 to the left. Since this is less than or equal to, that means 11 is a possible solution. So I'm going to put a closed circle over 11. And we're going to point an arrow towards all the smaller numbers because n is less than 11. Okay, there we go. Now let's test some solutions out in the original inequality. So let's test out n equals 10. So I have 3 times 10. Is it less than or equal to 33? Yep. 30 is less than or equal to 33. So that means 10 is a solution, and I've shaded in that direction, so I know it's okay. Next, let's test out n equals 11. So 3 times 11, is it less than or equal to 33? Yes, 33 is equal to 33, so 11 is a solution. Let's test out 12 while we're at it. N equals 12, so 3 times 12, it's not less than or equal to 33 because that's 36, right? So that means 12 is not a solution, and it's good that I did not shade towards 12. Number 3, we have x is divided by 2, that's all less than 25. So to undo dividing by 2, we're going to multiply by 2, both sides. Right, these 2's cancel each other out, so we have x is less than 50. So I'm going to put 50 in the center. And when I test it, I'm dividing by 2, so let's skip count by 2's here, so we don't end up with fractions. So 52 and 48 to the left. So x is less than 50, and that means it's an open circle over 50. and we're pointing an arrow towards the left to all those smaller numbers. So let's test it out. Let's say x is 48, and 48 divided by 2, is that less than 25? Yes, 48 divided by 2 is 24, and 24 is less than 25. So that means 48 is the solution. Let's try 50. X equals 50, so 50 divided by 2. Is it less than 25? Nope, it's 25. Those are not equal. This is a false statement, so that means 50 is not a solution, and that's why we have this open circle over it. Our last one, k plus 2.5 is greater than or equal to 10. Since we're adding 2.5 to k, I'm going to subtract 2.5, opposite operation, and I'm also going to subtract 2.5 from 10. So we're left with k on the left-hand side is greater than or equal to, well, 10 minus 2.5 would be 7.5. So I'm going to put 7.5 in the center here. We'll put 8 to the right and 7 to the left. Since k is greater than or equal to 7.5, we're going to use a closed circle to show 7.5 as a possible solution. And greater than means all those numbers to the right. So let's test out k equals 7. So 7 plus 2.5, is it greater than or equal to 10? Nope, when I add them we get 9.5. It's not greater than or equal to 10, so that means 7 is not a solution. Let's test 7.5. So 7.5 plus 2.5 is greater than or equal to 10. Yes, these add up to 10. It is equal to 10, so 7.5 is a solution. And the last one we're going to test here is 8. So 8 plus 2.5, is it greater than or equal to 10? Yes, when I add those, 10.5 is greater than 10, so 8 is a solution. So it's always a good idea to test it out, and you don't have to write it out, but mentally substitute in those numbers back into the original inequality, and that'll tell you whether you should use an open circle, closed circle, and which way you should be shading if you shaded it in the correct direction. All right, so try out the practice problems, and if you have questions, I'll answer any questions that you have in our video call. All right, talk to you soon. Bye.